This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 95. Today's presentation, Mesoanalysis of the February 24th, 2022 Convective Winter Precipitation Event in eastern Oklahoma and northwestern Arkansas. Our presenter is a former Satellite Liaison and current Weather Service meteorologist at the Forecast Office in Tulsa, Michael Bolin. And our facilitator for today is Mike Stavish, the Science and Operations Officer at the Weather Forecast Office in Medford, Oregon. Just a few reminders before we get started today that this session is being recorded, that there will be an opportunity for Q&A after the presentation, and we particularly encourage questions and comments on the subject matter from our field offices and regional headquarters. We also encourage attendees, if you haven't changed your name or signed in with your full name, please specify your full name when asking a question in the chat. That way we can follow up if we need to, if you're using an office account or something like that. We're always looking for future presenters as we head toward the 100th Satellite Book Club. We're particularly looking for presenters from our field offices. So if you are at a field office and you have a satellite application that you'd like to share, please don't be shy. We'd love to have you present, and we can work around your schedule if necessary. The training team can help create training materials that may be unavailable, and Brian Mata, the Office of the Chief Learning Officer, can help with that. I'd like to thank the Tower S team, particularly Kashad Bowman, the Office of the Chief Learning Officer, the GOZAR and JPSS programs, and our facilitator for everything they do behind the scenes to get us to today. And of course, thanks to you for being with us. Without further ado, let me formally introduce our presenter, Michael Bolin, who graduated from the University of Oklahoma with a bachelor's degree and master's degree in meteorology, and when his research was focused on severe storm radar research. Michael began his career with the Cooperative Institute for Meteorological Mesoscale Studies as a satellite liaison for the Warning Decision Training Division for 3 years, then for the Storm Prediction Center and Hazardous Weather Testbed for another 3 years. As a satellite liaison, he focused developing training materials for weather service forecasters and helped lead an experiment every year in the Hazardous Weather Testbed for new satellite-related tools planning to be integrated into weather service operations. In 2020, he joined the Weather Service office in Tulsa, and he's been working as an operational meteorologist ever since, which brings us to today's presentation. Michael, welcome to the book club.
Thank you, Jordan. Glad to be here. So good morning or afternoon to all of you out there. Again, thanks for having me on this talk. I'm excited to present some of the things that we saw from a convective winter precipitation event here in eastern Oklahoma, northwest Arkansas this past February. So throughout this presentation, I'll focus on a few of the satellite signals we saw leading up to this event and compare that with some other analyses throughout the event. So I was working the overnight shift, the midnight shift during this event, so leading up to the precipitation that started in the early morning hours on the 24th. So we go on the next slide. We'll give a brief little overview of the event. So actually the day prior, on the 23rd, we had a heavy sleet event move through our area, where some locations saw upwards to 3 inches of sleet. You can see a picture there. This is from the Fort Smith, Arkansas area of just mounds of sleet coming off of roofs and piling up. It was around for a while, caused lots of havoc on the roadways. Sleet is hard to move off the road, harder than snow around here. So it was quite the event the day prior. So because we had that the day prior, we had very cold air already in place, which is a little different, setup than what we typically see over a lot of our winter events around here. The cold air arrives right with the precipitation, almost, especially for our mixed precipitation events. So this is a little bit different in that we had very cold air in place. The temperatures starting out on the morning overnight of the 24th and into the morning hours were in the teens to low 20s. So I had very cold air at the surface. Had a strong upper trough, kind of slowly progressing through the western conus that gave us that round of precipitation on the 23rd, and then was ejecting out into the plains on the 24th. And this event again led to many travel impacts across our area, with interstates having to be shut down, many car accidents, things like that, mainly travel impacts to our area. So as we move ahead, first I'm going to show what has been the background on the first two images, but this nighttime microphysics RGB loop. So this is kind of really the imagery that got me and the other forecaster, the lead forecaster that was on shift with me that night, kind of thinking of what was going on here and how we could compare this to some other things to see what was going on. So you see at the initial outset, have high cloud cover in the red clouds, and some enhanced clouds within those high cloud cover. You see kind of the oranges, kind of the pixelated orange colors there. That was actually associated with some areas of freezing drizzle that we had moving through northeastern Oklahoma on the night of the 23rd into the early morning of the 24th. So had some pretty good freezing drizzle across the area. On top of that, sleet on top of the roadways, which just kind of made things more slick. But the main thing that really got our attention was the low clouds that you see there surging northward. So we had low clouds in place with kind of the pale yellow color, and then saw those different kind of grayish blue colors surging northward atop of the other low clouds. So this was a question that the forecaster on shift asked me whenever he saw this. He was like, so what's going on here? So this is kind of what really got us thinking. So you can see kind of have those, I kind of was talking about that the low clouds that are already in place, kind of associated with the cooler air mass closer to the surface, and then the warm advection regime that was spreading atop those clouds, bringing the kind of warmer, in quotes, water clouds northward atop those cooler clouds. I'm kind of showing the start of the warm advection regime that we were expecting across the area that would be cause the onset of precipitation that morning. So from this, we were kind of inferring, okay, this could be getting that warm nose getting a little stronger. Might be expecting some more freezing rain than sleet like we saw the day previously. Also can help to steepen those mid-level lapse rates, creating a little more instability. And then at the very end of the loop, we see the convective initiation at daybreak across eastern Oklahoma there. So moving ahead, I wanted to kind of compare this and see what was going on, looking at some of the SBC mesoanalysis graphics. So this is max 2 to 6 kilometer lapse rates. So you can see we'll kind of be focusing on where that red star is in far eastern Oklahoma, northwest Arkansas. That's kind of our main area of focus throughout this event. But you can see starting at 3Z, the lapse rates are pretty modest, but they really increase up to around 8.5 degrees per kilometer there by 12Z. So the steepening of the mid-level lapse rates there was, kind of helped confirm that hypothesis that we had, that we could see a little more instability forming across the region. And then, so going on with that, moving ahead to the next slide, compare that to the MU Cape across the area. Starting out 3Z, didn't really have any. And then by 15Z, the time when storms were really going across this area, had upwards of about 500 joules per kilogram across the area, which is pretty good around here in a very cold air mass in February. So that was, so again, that was a good confirmation for what we were seeing in the satellite. You also see in this image that the parcel that was creating that most unstable cape is being lifted from somewhere between like 1 to 2 kilometers, according to these graphics. So kind of keep that in mind as we look at a few more things here as we go throughout. All right, moving ahead, comparing to some of the upper air analyses here from SBC. So this is looking at 925 and 850 millibars at 0Z, and then at 12Z on the bottom on the 24th. Again, focused along that red star. So we can see at 925 that we have very cold air mass in place, the whole area below freezing at 925. So a pretty good cold layer underneath the warm nose. But we can see at 850 that the 850 front is really begin to shift a little bit northward between 0Z and 12Z. So that's again a signal of that warm advection starting across the region. That warm nose kind of strengthening throughout eastern Oklahoma and northwest Arkansas. So next we'll kind of scroll through a little bit of a few soundings here. So I'm going to look at some NewCap soundings and then also some observed soundings from radiosondes from the Springfield office as we step through here, kind of stepping through in time. So I'm starting out the afternoon of the 23rd. So this is after most of the precipitation on the 23rd has moved out of our area at this time. I'm just kind of getting a starting point for what the profile kind of looks like and how it changes throughout the next 12 to 24 hours. So this is from southeast Oklahoma. So we see a couple things we see here are like near isothermal layer, kind of in the mid levels. Again, we'll focus on kind of these mid levels here, about 800 to 500 millibars, where that red oval is as we step through. One thing of note here from these NewCap soundings is that while the surface temperatures were quite a bit too warm here, I'm really focused on the mid levels for this case, where the NewCap soundings showed pretty good utility for analyzing some of these mid-level things that were happening that we see in the satellite images and the analyses through here. So these were good and able to give us a picture of a profile with us not being, Tulsa's not an upper air site. Our closest site was Springfield during this time because Norman wasn't doing soundings. They were still converting their sounding building over to using hydrogen. So they weren't launching soundings during this time frame on the 24th. They launched some soundings on the 23rd, but not on the 24th. So these were good to have to get a little bit of a picture of this mid-level profile. So stepping ahead, so going from 19Z on the 23rd, this is the 0Z Springfield sounding on the 24th. So again, it kind of shows that near isothermal layer, a little bit of a warm nose there in the mid levels at about 800 millibars. And then a pretty moist profile up to 700 millibars. So this is as precipitation is kind of exiting, that initial wave is kind of exiting the area here. So then we step ahead to the next NewCap sounding, which is around 8Z on the morning of the 24th. We see quite a bit of change here in the mid levels. So we can see where that warm advection is beginning to happen. See a little bit of a deeper warm nose, warming and drying in the mid levels. The lapse rates, those mid-level lapse rates have definitely steepened over time here. And as we move ahead to the next Springfield sounding, we can see that kind of gives us a little bit of confidence in those NewCap soundings here, because we see pretty much the same thing happening in the Springfield sounding here at 12Z on the 24th. So Springfield is a little bit northeast of our area, so not a perfect representation of what's going on in our area, but pretty close to our northwest Arkansas areas of responsibility. So it does show some of those same things we were seeing in the NewCap sounding there, except the much colder surface temperatures and a little bit more of a moist near surface layer, maybe seeing some freezing drizzle and things like that during this time, like we saw across northeast Oklahoma during the nighttime hours there. So also we see some increasing low to mid-level winds, that 850 jet kind of starting to pick up. And one thing to note, again, with looking at the Springfield sounding across our area that we were focused on, we were mainly be south of that 850 front. And so we'd have a little more southerly winds, southerly and southwesterly than what we see here at Springfield. But again, kind of shows that jet starting to pick up, the warm advection kicking up over the frontal boundary just prior to initiation here. So step ahead to the next NewCap sounding. So this is 19Z. So this is pretty much after the precipitation has ended across our area. So you see where the big mid-level dry air has come into the region. The profile has gone really dry at the mid levels, and precipitation has ended across the region here. And stepping ahead to the Springfield sounding, we see the same thing happen there in another few hours, where they're still hanging on to maybe a little light precipitation at the surface, but mostly precipitation has ended at this time. All right, so I'm gonna go ahead to another, show the mid-level water vapor imagery here. So a couple interesting things that we noted from this was, you can see the exiting jet streak that kind of brought that first round of precipitation is moving up through the Midwest, up into the Great Lakes region. But we see a secondary jet streak kind of associated with the trough beginning to kick out into the plains, beginning to kick out of the Rockies and into the plains, coming out of northern Mexico and moving up into southeast and eastern Oklahoma throughout this loop. And then you see initiation occur there kind of towards the end of the loop. We can also see the dry air beginning to filter in and out of the desert southwest and northwest Mexico there, coming in throughout the loop, and then really coming in at the end of the loop when we really saw those soundings dry out. But one thing to note here was that the convective development was really in that favored region of the jet circulation between the two jet streaks, with the right entrance region of that exiting jet streak and the left exit region of the new jet streak coming up out of northern Mexico and into our area. So that wanted to compare that with some of the upper air analyses. So looking ahead at the 300 millibar chart, we can see those jet streaks. You can go ahead to the next slide there, Kashad. Yeah, you can see those jets, kind of the main strong upper jet moving through the Midwest up into the Great Lakes region at this time. But then you see a little more, not as strong, but a subtle jet streak coming out of northern Mexico, coming into areas of eastern Oklahoma, northwest Arkansas, there by 12Z, in that kind of favored region of convective development there atop the 850 to 700 frontal boundary, where our initiation occurred, really along that boundary during this time. So we had the large scale lift from this jet from the trough starting to overspread the region, really helped to get that initiation going. And again, we'll just kind of step through the soundings here real fast, kind of showing this, just kind of focus on the upper level winds at this point. So you can see from Springfield here at 12Z on the 24th, we see the, or this is a 0Z on the 24th, I think, that we see the, see that initial jet streak kind of exiting the area. And as we step forward in time, this one is, I think we skipped one there, but we saw at 12Z how the winds, if you can step back one, Kashad there, I think we got ahead there. You can see the winds kind of come down a little bit in the upper levels, and then as we move ahead to 0Z on the 25th, we can see that jet really starting to enter the region where we have 150, 155 knot winds there, around 200, 250 millibars coming into the region. So we saw that initial jet there, and then the winds kind of weaken a little bit, and then they come up across the board here as we move to 0Z. So as that jet entered the region and then was progressing through the region during this time. So it was nice to have that. Also compared well to the water vapor imagery they were looking at, and able to see that in real time was good for us, knowing we would be in that favored area for convective development there in eastern Oklahoma. All right, step ahead here real quickly, kind of look at what what happened here. So this is the IR imagery along with some GLM imagery from the Sierra site. So you see in this loop, you see the convective development happen there in eastern Oklahoma. See some surges, some pretty good surges there in GLM lightning. This loop is only every 30 minutes to try to keep the size of the file down a little bit, but looking at this in real time, we saw quite a bit of surge and lightning activity across the area as really as it was moving into that instability axis that we looked at previously across far eastern Oklahoma into western Arkansas. Looking also real quickly, just kind of wanted to compare to what we were, you can move ahead to the next slide, kind of compare to kind of some of the model forecasts that we were looking at. And stop, sorry, my dog wants to go outside. If you can hear those bells ringing, that's what it is. I'm looking at some of the model forecasts that we were looking at. So this is the HER and the NAM. Both showed some hints of convective development, more so the NAM for sure. Has that more cellular development across most of our area than the HER might have had, but the intensity of the convection isn't quite there in these model forecasts. So it was helpful just kind of seeing the instability change in real time and some of these things that I've talked about, being able to show that we might expect some more convective activity across the region than maybe what some of these forecasts that we had been looking at to make our forecasts were showing. So just kind of wanted to show that real fast, just kind of comparison to what happens on this next slide here, which shows the radar loop from the event. So we see convection beginning there around daybreak, southeast and eastern Oklahoma, and then really intensifies as it moves into, again, that instability axis where the strongest instability and lapse rates that we saw were centered there across eastern Oklahoma and northwest Arkansas. As the storms really begin to move into that area, they intensify and actually end up producing, heavy convective winter precipitation along with some hail in some of those storms as well. So moving ahead to the next slide, I'll kind of show a little bit a few of those products and pictures from the event. So we see we did issue several special weather statements for small hail across the area. So this one's in eastern Oklahoma. You can go ahead and kind of flip through these, Kashad. There's a few animations here. So then moving up into the Fayetteville area, where we got kind of a lot of our reports of hail. We're in that northwest Arkansas corridor. And so if you skip ahead to some of these pictures, I'll show a few pictures of the hail we saw. So small hail, the kind of dime to penny size at the largest, but still pretty good for a winter event across the area with a cold air mass. You're getting freezing rain and hail along with some sleet. So that was pretty atypical for this time of year. So skip ahead to the next couple of pictures. We also did see some more. There's a nice picture with lightning CG strike as the sleet and freezing rain are falling. And we did see more freezing rain with this event than what we saw the day previously. So you can see some icing there on some of the trees. With the convective nature of the activity, the accretion and ice accumulation rates probably weren't as efficient as they would be in a wider precipitation event, but it came down pretty hard, pretty fast. So we did have some icing, especially across Arkansas. And I think there's one more. Yeah. So there were some trees got uprooted, some trees got downed. So some icing across the area. This was mainly a travel impact event. Didn't see much in the way of power outages in our area. More of the ice storm was over in kind of eastern Arkansas, where they saw more power outages, but big travel impacts for sure from this event. So thank you. I think that's the end, and I will be open for questions, conversations, snide remarks.
Okay, Michael. Hey, thank you very much. Lots of stuff to look at there, and lots of stuff to be interested with regard to convection and winter weather and all kinds of challenges you had on the midnight shift. Hey, I'm going to encourage people at this point in time to stay on the call if you're out in the field forecast office or regional headquarters. Any other attendees also stay on for the discussion here. You can place your questions for Michael in the chat. That would be terrific. I believe Tristan has also placed a link there for the short survey. If you could take that, we would appreciate that. And also, please specify your full name in the chat when asking a question so we can address you and get back to you appropriately. Also, before we begin the Q&A, let me just mention that a week from today, on Thursday, May 5th, at 12 p.m. Eastern, Jarrell Torres, Research Associate and JPSS Satellite Liaison from CIRA, will discuss JPSS applications, datasets, training resources, and user feedback. And also, please contact Tower S, Lee Byerly and Kashad Bowman for questions about the SBC or configuration of satellite products. So let's move right into it here, Michael. I've got one question from Bill in the chat here. Did the public feel prepared for this event?
Yeah, that's good. That's a good question. I think we did pretty good leading up to the event of messaging the potential for very heavy sleet and freezing rain across the area. We were, doing briefings and things like that to EMs and partners several days beforehand, leading up to the event. It was a pretty well forecasted event, both model-wise and in the office. So I think we had pretty good preparation, pretty good lead time on what was going to happen. Maybe not to the extent of 3-4 inches of sleet falling across the area, but we were pretty good at mentioning that there could be convective elements, seeing thunder sleet, as it might be called, or thunderstorms with freezing rain. But being able to that we might see some of those convective elements happen with this event, and see some of those heavy precipitation rates with sleet and freezing rain falling. So I feel like we messaged the event pretty well. How well the public takes that in and is prepared is hard to tell. But I think schools closed, offices closed, and things like that beforehand. So there wasn't any of school buses out getting stuck or kids getting stuck going to school and things like that. So I think that our briefings and things like that helped keep those things closed, tried to keep people off the roads, knowing that it was, especially this event on the 24th occurred, kind of right at the morning commute time. I remember going home on my midnight shift after this. There were several people stuck on the side of the road, and tow trucks out trying to get people out of ditches and stuff on the way home. So the roads are pretty slick, and hazardous had those impacts. But I think we prepared people as much as we could for this event. Again, it was pretty well forecast.
Yeah, thanks. I was thinking as you were presenting, as you came in on shift this evening of this complex sequence of events here, you weren't greeted with an easy night. You knew you were going to have some challenges ahead of you. So that's not a relaxing midnight shift per se, but you did have some challenges. And
Yeah.
Bill mentioned in the chat there that you were able to use the soundings, the NewCap soundings certainly seemed of particular value this night to you. Can you comment on those?
Yeah. Like I said, and I forgot to mention this in the presentation, but I want to mention it now. But thanks to Jarrell Torres for getting these soundings for me after the fact, as our archive here didn't have the soundings in them. So big thank you to Jarrell for being able to get those to me after the fact. So I wanted to mention that in the presentation, but I forgot. But I'll mention it now. But yeah, they were pretty helpful to look at, and especially, as I said, kind of looking at those mid levels there. Trying to get the seeing the warm nose get a little stronger, and the drying going on in the mid levels there, and the lapse rate steepening, I thought was of a pretty good value, and it compared pretty well to what we saw in nearby observed soundings, kind of in the in-between time frame. So I think they showed pretty good utility in that sense. Again, the surface temperatures were way too warm, so getting the actual precipitation type from the sounding wouldn't be as as able to do that, I guess, with the surface temperatures. But when you can modify the surface temperatures and the sounding to kind of what's being observed. But really seeing that warm nose helps with the precipitation type forecasting for sure. At
Yeah.
levels.
Brian, that might be Brian Mata. I don't have a last name here. I think it's Brian Mata asked if you considered an MDS for this event. Did you call for an MDS, or could it or would it have helped?
See, I'm trying to think back. I think we had one. I'm not sure. I'd have to. All these events run together, especially with our busy spring that we've had so far. But I think we did have one for this event, if I'm not mistaken. I'd have to go back and look. I don't think that we called for one ourselves, but yeah, that definitely would be more helpful being able to see, particularly in like seeing the initiation stage and seeing some of the cloud tops and those things during the storm activity to be able to see which storms are kind of maybe getting a little stronger.
Okay, we had another question in the chat here from Juan Meng. Asks, was the precipitation on the 24th mostly snow or some other form of precipitation?
Yeah, so it was mostly freezing rain and sleet. We had some snow kind of more up closer to Tulsa, and north of Tulsa was a little more snow, where there was the warm nose wasn't as prevalent up there. And you can kind of make that out in the nighttime microphysics RGB, seeing the warm advection coming across the region. Is a little weaker up across kind of north of Tulsa, north of I-44. So we did see some snow up there, mainly light, pretty light, but all the convective precip was sleet and freezing rain and hail.
Okay, thank you. Michael, one thing that occurred to me is when you were pointing out, watching the the changing thermal structure of the atmosphere through the night by watching the nighttime microphysics, that was interesting to me because we, typically aren't dealing with a lot of mixed precipitation events in the West, and we certainly use this product a lot, and mainly to differentiate fog and warmer low clouds from colder mid and high clouds, and just to get a good three-dimensional picture of the atmosphere. But you certainly opened my eyes to be able to use this product to just watch for features indicating, hey, here's a good representation of the changing instability, watching the warmer clouds surge northward, et cetera, and using that in combination with the soundings to confirm the changing instability was certainly something I hadn't really practiced before. So thank you for that.
Yeah.
Do you use, was it expected that you'd be using the nighttime micro in that context?
Not really. Yeah, it was kind of just as I said on this night, it was actually the lead that was on shift with me that really first got me thinking about what was going on here. I mean, I had it up on my screen and was looking at it, but wasn't really comprehending or thinking about it at this point. I was doing the forecast this night, I think, so I was kind of starting on getting into the forecast and getting into the grids. But he was watching it, and so he just kind of turned around and asked me, he's like, so what's with the different colors here? What's going on here? Why are there we have those yellow and then kind of the grayish blue clouds? And like you said, we're used to kind of looking at it for those grayish blue areas of fog, and looking at it for areas of fog like that. But I kind of looked at it and I was like, that's a good question. And so we kind of started talking about it and kind of doing a little bit of research on it. And I was like, well, I think it's that kind of this cooler regime. Again, we had very cold surface temperatures and near surface temperatures. This cooler regime, low clouds, and then the kind of warmer regime, low clouds surging northward atop those clouds. And so looking at it that way kind of started to get the mind turning of, okay, so how does this relate to what's going on in the whole thermal profile and how it's changing. So yeah, it was kind of a unexpected thing, but ended up definitely looking for a new way to use it in future events for sure. Especially we get a lot of mixed precipitation events around here, so kind of looking to see if you can see that in other events will be interesting as well.
Okay, yeah, I think Kevin Thiel had a question in there, and he was following up with that maybe that was already answered, but he was regarding the nighttime micro, and did that give you details about the convective precip that maybe you couldn't identify had you only used radar, but hang on for that one for just a minute, because he thinks he had that one answered. So I want to move forward to Chris White. He said, good use of the nighttime microphysics to assess the physical and temperature differences in the cloud layers associated with an overrunning event, and also clever use of the data and imagery. And he says, good to see the use of new caps in this event to assess the lapse rates aloft, along with the temperature dew point structure associated with the warm nose. So he commends you on that. Scott Lindstrom has also placed a couple links in here for folks to investigate regarding some mesos. So I'm not sure. Yeah, he's providing links to which mesos were called for that night.
Okay.
One thing I had to question you, Mike. It looked like the convection actually came in late. Were you still on shift when the convection was going off, or started?
It was kind of just starting as I was going off.
Okay. Yeah.
Off shift. Yeah, we kind of had some lighter precipitation up here in the Tulsa area as I was getting off. Again, we had that kind of freezing drizzle overnight, and then had some lighter sleet stuff up here around Tulsa. But yeah, the main convective event was just kind of getting started, kind of southeast of Tulsa, as I was getting off shift and going home. So yeah, I wasn't still on shift once the convection started. That was the day shift, but on leading up to the initiation and everything was our shift.
Okay.
Yeah, it kind of started there about 13 to 14 Z or so is when it kind of started.
Okay, let's see. Anybody else have any more questions for Michael? Just looking at the chat box here. Not seeing anything. Okay, just a reminder for folks, please see the interview or the survey linked by Tristan at the top of the chat window if you want to take that. The Satellite Book Club would certainly appreciate that. And I think we'll go ahead and turn things back over to Jordan at this point.
All right, thank you, Mike, and thank you, Michael, for that great presentation. And thanks again to all of our audience for being with us today. We continue the Satellite Book Club every week on Thursday. Next week, Thursday, May 5th, 12 noon Eastern time will be no exception when we'll have Jarrell Torres, the JPSS Satellite Liaison, talk about JPSS applications. And I'm really looking forward to that. I hope you are too. In the meantime, if you have any questions related to satellite imagery in AWIPS, we have a Tower S team that is ably available to assist. So please do not hesitate to get in touch with them if you have any questions about satellite imagery and products in AWIPS. With that, thank you so much for joining us today. Hope you'll join us next week. Until then, take care. Bye now.